So today we're going to work on a couple of different rules. We've got the product rule, and we're going to work on our quotient rule, and we're going to derive some trig derivatives, and so it'll be a good time. Our first rule is the product rule, and so what this rule is telling us is if we have a function times a function and we need to take the derivative of this thing, we're going to set this up kind of a different way, right? If it's a derivative times a constant, that's just our power rule typically. But what happens is when we have a function, like in example 1, times a function, we need a better way to handle it. And so our formula for this is when we take the derivative, it's going to be f of x times g prime of x plus g of x times f prime of x. And so this is going to allow us to take derivatives of things, products, that normally we couldn't take, right? So on example 1, if instead of having 2 terms here, say this had 11 terms, and this had, whatever, 5 terms, you wouldn't be able to FOIL this out very easily and then take a derivative term by term by term. So we need another way to do this. And obviously you guys could FOIL this out and take derivatives, but we're going to use the power rule, or the product rule, excuse me, to take this derivative. We can look at this another way. There's another kind of formula for taking the derivative d by dx of some function u times some function v. We could write this as the derivative would be u times v prime plus v times u prime. Just different notation means the exact same thing. So here's what we're going to do. We're going to do example 1. We're going to find the derivative of y. We're going to set this up a little bit differently than we've done some problems before, and I'm going to set this up kind of step by step. So I'm going to call this f of x. So my first function is going to be f of x. And so when we write this out, I need to figure out what f prime is. So f prime is going to be the derivative of 3x is 3, and the derivative of negative 2x squared is negative 4x. My second function is going to be g of x, and we need to do kind of the same thing. We need to find the derivative of g. Well, the derivative of g of x, the derivative of 5 is 0, and the derivative of 4x is just 4. So we can write all of this out. So here we go. When we take the derivative of this guy, y prime, let's use our formula up here. It's, first off, it's f of x. So f of x is just 3x minus 2x squared, close parentheses. Our next function that we write is g prime of x. Well, g prime of x is 4. Let's make that look like a better 4. G prime of x is 4. And then we're adding g of x. Well, g of x is 5 plus 4x. And then we're multiplying that by the derivative of f prime. So the derivative of f, not the derivative of f prime, but the derivative of f. And so we're multiplying this by f prime, which is 3 minus 4x. So the big deal with this at this point is that you need to stop and take a look at it and see, can you simplify this? Can we factor anything out? And so we're always looking for common factors. And if we can, we want to factor that out. So it looks like we have no common factors. The only other thing we're going to do is we're going to take this 4, this coefficient, we're going to put it in the front. So we have 4 times 3x minus 2x squared plus 5 plus 4x times 3 minus 4x. And this is all we can do, 4x. That's our final answer. The temptation, let's talk about a couple of things. The temptation is that we're going to, we can FOIL this out. We can do all these wonderful things, and we don't want to do that. We want to leave this as it is, because what's going to happen here in a couple of days is we're going to set this, and even today we'll do some of this, we're going to set this equal to 0, and we're going to solve for the value of x. So if you were to FOIL this thing out and then combine like terms, you would then have to factor it to simplify it. So there's our first problem. Second problem, 1b. So we're starting to mix things up. we've got 2x times cosine of x, so we have a function times a function, and we're going to use the product rule for that. The thing that I want you to be aware of is we're going to start mixing these different derivatives up, or these different functions, right? So we've got product rule. This is not a product rule. 2 times sine of x is not a product rule. That's just our regular derivative rules, so not a product rule. Let's let's set this up kind of like we set the other one up. Let's call this f of x, and we'll call this guy g of x. So the derivative of f of x, so f prime of x is, well, the derivative of 2x is 2. And the derivative of cosine of x, so g prime of x, is negative sine of x. And now we're ready to take the derivative. So we've got our y prime is equal to, here's our formula, f of x. So f of x is 2x times the derivative of the second thing. So the derivative of g of x is negative sine of x, plus f of x times, times the derivative of the first thing. So the derivative of f would be 2, and then times cosine of x. We don't want to forget, we now need to take the derivative of negative 2 sine of x. So the derivative of sine of x is cosine of x, but we have this negative 2, so it's negative 2 cosine of x. And that's done, we've taken the derivative. We need to kind of combine like terms and look at a couple things, see if we can simplify anything. So it looks like for this first part, we got our negative and our 2x, so I'm just going to write it as negative 2x sine of x. And then I've got plus, looks like 2 cosine of x minus 2 cosine of x. And so it looks like my cosines of x reduced to 0, and y prime is negative 2x sine of x. And we're done. So that's our product rule, and we'll use it a lot. So the product rule, anytime we have a function times a function, we're using the product rule. Constant, so a number times a function, is not the product rule. The next one is our quotient rule, and this seems to be the one that students struggle with the most. So let's kind of write this out. So we're taking the derivative, d by dx, of f of x divided by g of x. And the way that we write this, the way that we're going to take the derivative, our formula, is this is g of x times f prime of x minus f of x times g prime of x, and this is all over that bottom function, g of x squared. And so we have a little song that we can sing to remember this, and you guys can sing it or not. When I get back to class, I'll make you sing it, so we'll have fun, or get you to encourage you to sing it. So we can remember this another way. If we have d by dx of f of x over g of x, so it's the low value, low, times the derivative, so low d high, that means we're taking the derivative of the high function, minus our high function, so low d high minus high, times the derivative of the bottom function, so times derivative of the low, all over low squared. Low d high minus high d low, draw the line, square below. That's it. Remember this. For the product rule, right, if we're multiplying these two functions together, because our formula is all addition or multiplication, the order does not matter. You can do it in any order you want. For the quotient rule, because it's subtraction and division, it definitely matters. It definitely matters. So let's figure a couple things out. For this guy, we can do the same thing. We can say that this is f of x and this is g of x, and just kind of try and be consistent. So we know that f prime of x would be, so the derivative of sine of x is cosine of x, and the derivative of g of x, so g prime of x would be 3x squared. So when we take our derivative, it's our low function, so it's g of x, x cubed, d high, derivative of the high function, so cosine of x, minus high, sine of x, times the derivative of the bottom function, x squared. And this is all over my low function, x cubed squared. Make that a little better. So it's all over x cubed squared. We always, 100% of the time, want to take a look at this and see, can I factor anything out, simplify? And it looks like we can factor out an x squared. That's what it looks like. So let's do that. If I factor an x squared out, I'm going to use some grouping symbols, just some brackets. So if I factor an x squared out of that x cubed, I'm left with x times cosine of x. If I factor an x squared out of the other side, I'm left with a negative 3 sine of x. And that's all over x cubed squared is x to the 6th. We can reduce my x cubed over x to the 6th. And what we end up with is x cosine of x minus 3 sine of x over x cubed over x to the 6th. The bottom reduces to x to the 4th. And we are done. I'm going to, in the interest of time, I'm going to let you guys do 2b. So you're going to do this and then check it against the notes. I want to stress something here, and we teach you these rules, we learn these rules, then we jump in and we see, oh, it's a quotient, we're dividing, let's use the quotient rule. But this is not an efficient way to do this. If we have a quotient in the top, right, or so we have a quotient, excuse me, a constant in the top, it's going to be much easier to use a different strategy, right? We can write this as 9/5 times x to the negative 2, and we can take the derivative of this. It's pretty straightforward, right? So the 9/5 doesn't change, the negative 2 comes down, and this is x to the negative 3. So this is going to be negative 18 over 5x cubed. That's the derivative. If you panic, you can always use the quotient rule for this, but it's going to be a little more work, right? So the quotient rule would be low, 5x squared times d high, the derivative of 9 is 0, minus high times d low, so this is going to be, not 5, excuse me, 10x. Derivative of 5x squared would be 10x over low squared, 5x squared squared. And then you'd have to simplify that, and you should get the exact same answer, but it might be a little more work. So definitely don't do that. We're going to use the quotient rule, and we're going to get some derivatives of some other trig functions. And so we're going to start with tangent of x. And to derive this for tangent of x, we need to rewrite this. And we know that tangent is the same thing as sine of x over cosine of x. And we're going to apply the quotient rule because it's a quotient. So it's the derivative, so it's low d high, low times the derivative of the top function. The derivative of sine is cosine. Low d high minus high, so minus sine of x, so minus high d low. The derivative of cosine of x is negative sine of x. And this is all over low squared, so cosine x squared. And I'm going to use this white space right here just to say something. Cosine of x squared is the same thing as cosine squared x. These two things are the same thing, and they mean something different. These are not equal to cosine x squared. These two things are the same, just written differently. This is something different. So now let's clean this up a little bit. Here's what we've got. So we have cosine of x times cosine of x. That's our cosine squared x. And negative sine of x times negative sine of x is positive sine squared x over cosine squared x. Well, when I look at this, I see cosine squared x plus sine squared x, and I realize that this is 1. That's my Pythagorean identity, right? Cosine squared x plus sine squared x is equal to 1. Our cosine squared x doesn't change. Now we want to rewrite this a little bit better, and I know that the reciprocal identity, 1 over cosine squared x, this is equal to secant squared x. So the derivative of tangent x is secant squared x. So let's just fill this in. Secant squared x. We're going to do another one. We need to figure out what the derivative of secant of x is. Well, we're going to do kind of the same stuff. We're going to rewrite this as d by dx, because we want it to be a quotient of 1 over cosine x. And I know I just told you in this previous problem, like, don't take this with a constant on top and do it as a quotient rule, but this is how we're going to derive the derivative of secant x. So now we're going to just apply the quotient rule, right? Low, so it's cosine of x, times d high, low d high. The derivative of a constant is always 0, minus high, times the derivative of the bottom function, so this is negative, whoops, not negative cosine, excuse me, negative sine of x, all over low squared, so cosine x squared. Clean this up a little bit. It doesn't matter what cosine of x is. If we're multiplying it by 0, it goes away. And then I have negative 1 times negative sine of x, so that is positive sine of x, over cosine squared x. And this doesn't really help us, but if I look at this, I see that I could do some rewriting, and I've got a sine over a cosine, and that could be helpful. So I'm going to split this cosine up on the bottom as cosine of x times cosine of x. And I'm going to put my sine of x right there. So it doesn't really matter kind of how we put this. I can break this up as 1 over cosine of x times sine of x over cosine of x, and then we can do some little rewriting, right? I know that 1 over cosine, that's my reciprocal identity, that is secant x. And I know that sine over cosine is tangent x. And so that is the derivative of secant x. So let's fill on our chart secant x. The derivative of secant x is secant x tangent x. And we've got cotangent x and cosecant x, and we're not going to make you derive them, but what we can do is, I'm just going to give you the formulas. So there's some pattern here that you need to kind of remember. The derivative of tangent x is secant squared x. The derivative of cotangent is negative cosecant squared x. So there's a pattern. If you know what tangent is, you should be able to remember cotangent is just a little bit different. The derivative of secant x is secant x tangent x. And so the derivative of cosecant x is going to be, big shocker, cosecant x times tangent x. And this is everything we've learned so far is on our cold quizzes, right? So it's on our pink sheet. You have these trigonometric derivatives, and you have the product rule and the quotient rule, and we're starting to gear up for our first cold quiz. All right, let's do another one. So we're taking the derivative of 3x squared times tangent x. I know that that's a product rule because we have a function, this x squared times a trig value, a trig function, tangent of x. And so maybe we want to identify our functions, f of x and g of x, and we can figure out what these are, right? So f prime of x would be, the derivative of 3x squared is 6x, and I'm going to change colors just to be fun. So the derivative of g of x, g prime of x, is secant squared x. The derivative of tangent is secant squared x. So we're going to write out our derivatives, right? So it's our first thing. So it's f 3x squared times the derivative of the second thing, so that's going to be times the derivative of secant squared x, and then it's going to be the derivative of our first thing. We're going to add this. It's going to be the derivative of 3x squared, which is 6x, times our second thing, that's tangent x. We need to see if we can factor anything out. Simplify this. So f prime of x is equal to, it looks like I can factor out a 3x, and that's going to leave me with, if I factor a 3x out of this, I'm left with x secant squared x plus factor 3x out of 6x, that leaves me 2 tangent x, and that's my final answer. Okay, College Board, we just went to the next page. College Board loves these type of problems, right? And so sometimes we're given the values of a function and its derivatives, or the graph of a function, to help us evaluate the derivative of a product or quotient. And so they give us g of 2 is equal to 3, g prime of 2 is equal to 2. They give us all of these values. And then they tell us f of x is equal to the product of these two functions, right? And they want us to find f prime of 2. So essentially what we're doing, I'm going to start right here. We're taking the derivative of this. So the derivative of f of x is f prime of x. And the derivative of g of x times h of x, well, that's our product rule, right? So this is going to be the first thing, g of x, times the derivative of h of x, so times h prime of x, plus our second thing, h of x, times the derivative of our first thing, g prime of x. And so that's all fine. We took the derivative, and now we need to evaluate this derivative at f prime of 2. So for our second step, f prime of 2, we're just plugging in 2 for all of the x's. So this is going to be g of 2 times h prime of 2 plus h of 2 times g prime of 2. And now we can just plug values in and work our way through. So g of 2 is 3. And h prime of 2 is 5. And it's a product rule, so we're adding h of 2. Well, h of 2 is negative 1. And finally, g prime of 2. So where is g prime? G prime of 2 is negative 4. So we're going to, 3 times 5 is 15, and negative 1 times 4 is positive 4. So my final answer is 19. So we take the derivative, we are evaluating it at these different points, and this is what we get. And so we had to use a product rule to figure this out. This is a very common College Board AP exam style question. You're going to see a question like this on your exams with me, and for sure on the once you take the AP exam. So now we've got graphs, and they want us to use the graphs of f and g to find the following if they exist, right? Just because you have a graph of something doesn't mean that all these values exist. So let's start with 5a. We have h of x is equal to the product of these two functions, and they want us to find h prime of 1. So that's not too bad. We just need to take the derivative. H prime of 1 is equal to f of x times g prime of x plus g of x times f prime of x. We plug in 1, right? H prime, whoops, and I put that was a 1, excuse me. So now h prime of 1 is equal to f of 1 times g prime of 1 plus g of 1 times f prime of 1. You're probably wondering, what in the world, how are we going to get that? Well, we're going to use our graph. And so let's get a little notation going. We're looking for, let's start with f of 1. We need to figure out what that is. We need to figure out what f prime of 1 is. We need to figure out what g of 1 is. And we need to figure out what g prime of 1 is. And so let's take a look at our graph. We'll start with the easy stuff, f of 1. So if we come over to 1, we come up and we know that f is 1, 2, 3. So f of 1 is 3. And easily enough, g of 1 is also 3. So that's fine. Now we need to figure out f prime of 1 and g prime of 1. So here's where things are going to get a little bit trickier, right? If I'm looking at f prime of 1, that means I'm finding the rate of change of the function when x is equal to 1. So here's my function f. I'm finding this rate of change. So f prime of 1, looks like we're going to go up 1, 2 over 1, up 1, 2 over 1. So f prime of 1 is 2. The rate of change of that line at 1 is 2. And we just count the slope. This is pretty easy to do because it's a linear function, right? And that's kind of the only way this is really going to work nicely. So let's take a look at g prime of 1. So here's g. There's my function g. And what it's asking us when we're finding g prime of 1, we're finding the slope or the rate of change of the function g when x is 1. So it looks like that point, that slope right there is negative 1. So we have these values. We can go plug them in, or we can evaluate our derivative. So h prime of 1 is equal to f of 1 is 3 times g prime of 1, so g prime of 1 is negative 1, plus g of 1, which is also 3, times f prime of 1, so f prime of 1 is 2, and this is going to be negative 3 plus 6 is going to be 3. So that's not too terrible. Whoops, that should have been a 2. Tried to erase it and erase too much. So that's not too terrible. I want you guys to do 5B and check your answer with a copy of the notes that are uploaded. Just remember, it's the quotient rule. Sing the song, low to high minus high to low, draw the line, square below. You'll have to evaluate your graphs at x equals 6. 1, 2, 3, 4, 5. At 6, and you should be good to go. You guys are also going to do example 6. And remember, we're finding the points, which means that's an x and a y coordinate point, where the graph of f has a horizontal tangent line. That means that our derivative, the rate of change, f prime of x, is equal to 0. So anywhere we have a horizontal tangent line, we know that the rate of change is 0. So you're going to take the derivative of this, simplify it as much as you can, set it equal to 0, and solve. Once you get a value, you're going to take that value, because you're going to find the x-coordinate where this occurs. You're going to plug that x-coordinate back into this original function to get the y-coordinate, and you should be good. Check your answers with the notes that are uploaded on our calendar. So that's it. It's about 30 minutes of notes. I know it's fast, and I'll answer any questions I have when I see you guys on Monday.